Hi everyone, we're back with another video about our calculator. This time I've entered the function x equals, or x raised to the 1/3 power, or the cube root of x. There is a way to put in cube root of x like we would normally write it, but it's really just not worth it. On the TI-84s, it's better just to use exponents in this case. So, the thing I want to do today is talk about trace, zoom, and intersect. So the first thing I'm going to do is try to graph this. And wow, I was not expecting it to actually graph this far out, but it makes sense that it would because the cube root function grows very slowly. So even though I'm out here past 100, I am not even at 5 yet in terms of my y values, since 5 cubed is 125, for example. So, but the thing is, I want to look at the cube root from normal angle, and guess what? I screwed up. Well, purposely in this case, and I left my window in the format that it was in the last example. So, you can manually type in the values you want, or you can actually go to the next button next door, the zoom button, and you get all these options here. And one of the nice useful one is number 6, Z standard. That stands for zoom standard. And what that is that will change your window options to a negative 10 by 10 window. So that's basically the standard window we've been using so far. So I'm going to hit number 6. And notice now that our cube root function looks like it normally does. Voila, there it is. So let's examine this graph a little bit first. So one thing I want to do is show you an interesting thing that happens near 0. And what happens is, even though this looks like kind of just two reflective virtues of the square root function, notice that when they piece together at the origin, things get very vertical. So if you zoom in on 0, 0, we should get a the graph is going to start looking more horizontal the more we zoom in. So the first thing I'm going to do is I'm going to select zoom, and I'm going to select zoom in. And then it's going to give me a position to zoom into, and I can move left and right, up or down. So, but I want to center at 0, 0, and I hit enter, and notice that it will redraw the graph. And again, notice that it looks like it's going near vertical at 0, 0. Notice that the computer has a hard time displaying this, but I guarantee you that's what's exactly going on. So let's zoom in a little bit more. And notice that it's getting quite vertical, and we can even zoom in a little more. And now it looks almost like a straight line there. So let's go back to our normal zoom here, normal zoom, or we can just zoom out a bunch of times. And actually, you don't have to hit enter if you click the number. Okay. Enter pauses the graph. That didn't do that on older calculators. I did not know that. So we have our cube root function, and now we know how to zoom in and zoom out. There are other zoom options here. One we'll talk about later in the course is Z-trig. But that's all I'm going to talk about for zoom right now. So another function that's really good to use is trace. Trace allows you to move along the graph and get particular points on the graph. So if I move left or right, notice that it gives me kind of predetermined values of x, but I can actually type in my own values if I want to see what the value is at pi over 2, for example. It'll pick out pi over 2 and give me the corresponding y value. Now notice that this is all decimal approximations. Let me see, we can pick out 8, and that should give me 2. There you go. Negative 8 should give me negative 2. And so this is another way to quickly evaluate points. You can graph the function. The only difference here is if I try, for example, to put negative 27 in, it will say an error. And we'll go to the error. And the problem is that my x values are only defined from negative 10 to 10, so I can only input x values between there. So I can put in 10, and it'll show me, actually I can't even put in 10. So it has to be between negative 10 and 10 and not including it. So let's go back and go 9.9, 99, 9.9. And it'll give me the value, but as soon as I hit 10, it'll throw an error. So that's the trace function. And then finally, the intersect function. The intersect function basically gives you the point of intersection between two graphs. So let's graph two things here. So let's get rid of it. Let's graph the line 3x plus 4 and the line negative 4x plus 1. And I'm just picking these at random, so let's see if we can find a point of intersection. They should intersect somewhere. Ah, one of them's turned off. Nope, they're both turned on. So we're in graph mode, and so we want to know what's the point of intersection, because it does not look like it's on any integer values, so it may not be so easy to find. Normally these are both y equals, so they're equal to y, so algebraically we would just set them equal to each other and solve. But using the calculator, we're going to use second trace, and this will open up a bunch of calculate. And one of these is going to be intersect. So we'll go down here to intersect, enter, and it's going to ask you for the first curve. And if you go hit left and right, you'll just travel along there like the trace. So up or down cycles through the curves. So I'm going to hit enter to enter y1, and then again up or down cycles through the curves if you have more than 2. Hit enter again to select y2, and then it's going to ask for a guess, and you use your arrow keys to get as close to the intersection point as you can and hit enter. And the computer does some thinking, and it says that the intersection point is at negative 0.4285 comma 2.714. So that's the points of intersection there. And so you've now seen how to use the trace function, the zoom function, and the intersect function. In the next video, we'll use the intersect function to solve equations graphically.